Hi everyone, my name is Esmail, and today I will be going through the steps of how to solve a particular calculus problem. Let us take a look at the question. The position function of an object moving along a straight line is s at t is equal to 2t cubed minus 15t squared plus 36t plus 10, where t is in seconds and s is in meters. A. What is the velocity of the object at 4 seconds? What is the object's acceleration at this time? B. When is the object momentarily at rest? What is the object's position when it is stopped? C. When is the object moving in a positive direction, and when is it moving in a negative direction? D. Determine the total distance traveled by the object during the first 7 seconds. And E. Sketch a graph to illustrate the motion of the object. I want us to look at question A. The first part of this question is asking for the velocity of an object at 4 seconds. Immediately we know that this question has to do with the derivatives unit of this course, because in order to find the velocity of an object, we must first find the first derivative of its position function. Let us look over the question one more time and highlight key components. The position function of an object moving along a straight line is s at t is equal to 2t cubed minus 15t squared plus 36t plus 10, where t is in seconds and s is in meters. These units will come in handy when answering the question. What is the velocity of the object at 4 seconds? What is the object's acceleration at this time? When is the object momentarily at rest? And what is the object's position when it is stopped? When is the object moving in a positive direction? And when is it moving in a negative direction? Determine the total distance traveled by the object during the first 7 seconds and sketch a graph to illustrate the motion of the object. Part A is asking for the velocity and the acceleration of the object at 4 seconds. Velocity is the instantaneous rate of change. Thus, a tangent line at t is equal to 4 seconds is a good representation of the object's velocity at 4 seconds. In order to determine the velocity of the object, we need to find the first derivative of the function, which can be referred to as the velocity function. We will then plug in 4 seconds for time so that we can solve for the velocity at 4 seconds. Similarly, in order to determine its acceleration at the same time, we need to find its second derivative and plug in 4 for time. So s prime t is equal to 2 times 3t squared minus 15 times 2t plus 36. When we plug in the value of 4, we get 6 times 4 squared minus 30 times 4 plus 36. The object's velocity at 4 seconds is equal to 12 meters per second. S double prime t is equal to 6 times 2t minus 30. You plug in the value of 4 and you get 18 meters per second squared. Therefore, at 4 seconds, the object has a velocity of 12 meters per second and an acceleration of 18 meters per second squared. Part B is asking for the time when the object is momentarily at rest as well as the position when it is stopped. An object is at rest when its instantaneous rate of change or velocity is equal to 0. On the graph, its tangent line would be a horizontal line with a slope of 0. To answer the question, the first derivative will be set equal to 0, and we will solve for time. The times for which the velocity is 0 will then be plugged into the s of t equation. As we found earlier, s prime t is equal to 6t squared minus 30t plus 36. When we set this equal to 0, we factor out the 6 and factor the polynomial. We get t is equal to 3 and t is equal to 2. Therefore, the object is momentarily at rest at 2 seconds and 3 seconds. Now that we know the times when the object is momentarily at rest, we need to plug in these values, so 2 seconds and 3 seconds, into our original equation. S at 2 is equal to 2 times 2 cubed minus 15 times 2 squared plus 36 times 2 plus 10. This gives us 38 meters. S at 3 is equal to 2 times 3 cubed minus 15 times 3 squared plus 36 times 3 plus 10. This gives us 37 meters. Therefore, the object's position when stopped is 38 meters and 37 meters. Part C is asking for when the object is moving in a positive or negative direction. On a graph, when the slope of the line is positive, the object is moving in a positive direction, and when the slope of the line is negative, the object is moving in a negative direction. The blue line represents when the object is moving in a positive direction, while the yellow line represents when the object is moving in a negative direction. An important thing to note is that at 2 seconds and 3 seconds, the velocity is neither positive or negative, it is 0. To solve this problem, we're going to have to determine the critical values of this function. This includes turning points and inflection points. By setting the first and second derivative equal to 0, we can solve for these critical values. We will then create a number line plotting these values and then determine if the velocities are positive or negative between and at critical values by plugging in numbers into the S prime t equation. We've already determined that S prime t is equal to 6t squared minus 30t plus 36. When set equal to 0, t is equal to 2 seconds and 3 seconds. S solver prime t is equal to 12t minus 30. When set equal to 0, t is equal to 2.5. Now we need to create a number line with 2, 2.5, and 3 seconds on it. We will solve for the direction of the velocities between and at these values. So we're solving for S prime 0, S prime 2, S prime 2.3, S prime 2.5, S prime 2.7, S prime 3, and S prime 100. As we can see, the velocities are positive from negative infinity to 2 and 3 to infinity, while the velocities are negative between 2 seconds and 3 seconds. Part D is asking us to determine the total distance traveled in the first 7 seconds. This means that we need to take into account the distance traveled when traveling in the negative direction. To solve for total distance, we will need to determine the starting position, the distance at each of the turning points, as well as the final distance. This means that we need to solve for distance when t is equal to 0 seconds, 2 seconds, 3 seconds, and 7 seconds. This is done by plugging in these values for t in the original equation. In previous parts of this question, we determined that S at 0 is equal to 10 meters, S at 2 is equal to 38 meters, S at 3, 37 meters, and when plugging in 7 seconds to S at t, we get 213 meters. Redrawing the number line from part C will help us determine the direction traveled in each interval. Between 2 and 3 seconds, the object traveled 1 meter in the opposite direction. Between 0 and 2 seconds, the object traveled 28 meters, and in between 3 and 7 seconds, the object traveled 176 meters. The sum of the distance traveled per interval is 205 meters. Therefore, the total distance traveled during the first 7 seconds is 205 meters. Part E is asking us to sketch a graph to illustrate the motion of the object. In order to sketch a graph, we will need to determine the starting position as well as the distance and times of each of the turning points. This means that we will need to solve for the distance when t is equal to 0 seconds, 2 seconds, and 3 seconds, just like we did in the previous question. So we already know that S at 0 is equal to 10, and S prime t is equal to 0 at 2 and 3 seconds. And at S at 2, the distance is 38 meters, and at S at 3, it's 37 meters. Plot the points that we already know. In part C, we determine when the object is moving in a positive and negative direction. This comes in handy when sketching a graph because we need to make sure that all the slopes are positive, except for between 2 and 3 seconds when they are negative. Moreover, we need to make sure that at 2 and 3 seconds, the graph has an instantaneous rate of change of 0. A professional sporting career that includes this type of math is anyone involved in race car driving. It is vital for racers to drive at the right velocities during different parts of the race in order to beat their opponents. Commentators, coaches, and racers analyze measurements like velocity and acceleration throughout the race in order to predict outcomes and determine how successful a driver is. As a driver, it is important to understand when to slow down and when to accelerate, as this would help them turn a corner efficiently without losing too much speed. This question might have looked intimidating at the beginning, but I've hoped to clear up any misunderstandings. Thank you for watching.